Hi guys, hello, welcome back to my channel. Today we'll be looking at a sample Module 2, Pure Maths Unit 1, Internal Assessment. Without further ado, we get right into it. And it says 1a, given that 3 plus sine squared theta over cos theta minus 2 is equal to 3 cos theta. Show that cos theta is equal to negative a half. All right, so let me just start back by rewriting this. We have 3 plus sine squared theta over cos theta minus 2 is equal to 3 cos theta. All right, now in solving any equation, the first problem is that we don't like to have fractions. All right, that normally creates a problem for us. So we're going to get rid of this denominator down here, which is to multiply both sides by it. So I'm going to have 3 plus sine squared theta is equal to 3 cos theta into cos theta minus 2. All right, good so far. So we have 3 plus sine squared theta equal 3 cos squared theta minus 6 cos theta. Now, by just looking at this, you have square terms, you have non-square terms, which means that this is hinting at what we call a hidden quadratic. All right. Now, one of the things I can do, since I have cos theta, is to change the sine squared theta to 1 minus cos squared theta. So you have to know the identities. So let me say this. Recall that sine squared theta is really equivalent to 1 minus cos squared theta. All right, very important identity here. So what I'm going to do here now is to replace the sine squared theta with a 1 minus cos squared theta. So it's going to become 3 plus 1 minus cos squared theta equal 3 cos squared theta minus 6 cos theta. All right, we want to have all the like terms on one side. In fact, since it's a hidden quadratic, we're going to take everything to one side. So I'm going to have 3 cos squared theta. This minus cos theta is going to come over as a cos squared theta minus 6 cos theta. And of course, 3 plus 1 is 4, comes over as a minus 4, and everything is equal to 0. So what we have here is 4 cos squared theta minus 6 cos theta minus 4 equal to 0. And you know we got AC on it. So 4 times negative 4 is negative 16. So I want two numbers now. When I multiply them, I get negative 16. But when I add them, I get negative 6, which is my B term. Because we're treating it like a hidden quadratic. Notably, you can make a substitution. You can say let cos theta equal to u. But you don't have to do that. All right, so probably we could use negative 8 and positive 2. So I'm going to have 4 cos squared theta minus 8 cos theta plus 2 cos theta minus 4 equal to 0. All right, good so far. Now we're going to pair them off. So those two, these two. Over here, we could take out a 4 cos theta. All right. If you take out 4 cos theta, you're going to have cos theta minus 2. Over here, you could take out a positive 2. And you have cos theta minus 2. Remember that all this is equal to 0. So now you can say that either 4 cos theta plus 2 equals 0, or cos theta minus 2 equal to 0. So here you're going to have cos theta equal negative 2 over 4, or cos theta equal to 2. Now, of course, cos theta being equal to 2 is impossible. It's not applicable, since cos theta has a range between negative 1 and positive 1. So that's out. So over here, cos theta is equal to negative a half, which is exactly what we wanted. All right, so we can have QED. That's exactly what we wanted. All right, let's move on to part B. Hence solve the equation. All of this equal to 3 cos 3x. Well, what's the difference between this and the previous question? In the previous question, you had sine theta, cos theta, cos theta. Now you have cos 3x, sine squared 3x, and cos 3x. Now we have to learn to make comparisons in mathematics. So we had proven that cos theta is equal to negative a half. That's what it had broken down to. Now, what is going to happen is that all this is really going to break down. The only thing that would change is the angle, which will not affect anything else. So this is actually going to break down, or this implies that cos 3x would be equal to negative a half. That's how you make the comparison, right? So the angle change. So instead of being theta, the angle is now 3x. The negative a half will remain the same. All right. Now, we know that there are several angles that can give us this value right here. Now, of course, the fact that you have 3x is going to normally be 3 times the number of values you would normally have in this range, which is between 0 and 180. All right, so let's see what happens. Now, bear in mind that whatever angle we come up with, then we're going to have to divide this angle by 3. All right, let's go. Now, so I'm going to go for what we call alpha, which is a small angle, which is going to be cos inverse of the negative a half. I can even ignore the negative a half, because what the negative a half is telling me is that it's going to be in the negative quadrant. So I'm going to think about cos inverse of a half. I'm going to ignore the minus. This is going to give me pi over 3. All right. So when I draw my quadrant, I know that they're all, and you can use this, remember it, all science teachers are crazy. All right, all ratios are positive in the first quadrant, sine in the second, tan alone in the third, and cos alone in the fourth. But bear in mind that the cos was negative, so it's going to fall in these two quadrants, which here is going to be pi over 3 in this quadrant, and also in this quadrant is going to be pi over 3. Good. Now, what it means is that I can now say, since alpha represents my 3x, I can say that 3x is equal to, now bear in mind this is a 0 mark, and the angles are measured away from the 0 mark. All right, so I'm looking at from here, and of course the angle is between 0 and 180, which means I'm actually going anti-clockwise, because when you go anti-clockwise, it's normally indicated by a positive. So if I go from here to all the way around here, that's going to be 2 pi over 3. All right, continuing. If I go all the way around here, remember here is pi. And of course, you go pi over 3 more. So it's just like saying 1 plus 1/3. Or 1 and 1/3, right? Which is 4 over 3. So you're going to have 4 pi over 3. Now, what do I do to get the other angles? Easy. I can go one more revolution on all of these, because bear in mind, as we said before, we're going to be dividing whatever we get by 3. All right? So we can go one more revolution, and see what happens. So we just need to add 2 pi to these values. You can ignore the pi, add the 2 to each of them, and then of course you can recombine it with the pi. All right? Pretty simple addition here. So if I add 2 pi to 2/3, as we said, we just add 2 to 2/3, I'm going to have 8 pi over 3. All right? Now, don't watch the signs, because remember, of course, we're going to be dividing everything back by 3. So it would still work out. Now, if I were to add an next 2 to 8 over 3, would that work out? So let me say 8, 2 plus 8 over 3. No, that wouldn't work. That would be too much. All right. So here now, remember, we're going to have to divide out by 3. So I'm going to have x equal, if I divide this by 3, I'm just going to have 2 pi over 9. I'm going to have 4 pi over 9. I'm going to have 8 pi over 9. And those would be my answers. Now, notice that even though I have the angle in degrees, given all solutions in degrees in the interval 0 to 180 degrees, all right, notice that I work in radians. I'm working in radians because normally the questions in the exam are given radians. So probably I should change this to radians. And you know, this is going to be between 0 and pi, all right? Very important. Most of the questions that you'll get will be in radians anyway. So you have to learn to work in radians. Before I go to the next question, let me just change this to pi right here. Very important. All right, let's move into question 2. It says f of x is equal to 12 cos x minus 4 sin x. And given that f of x is equal to r cos x plus alpha, where r is greater than or equal to 0, and alpha is between 0 and pi. Of course, I'm changing 90 degrees to pi. Find the value of r and the value of alpha. So we're going to take a comparative approach here. So we're going to set that 12 cos x minus 4 sin x is actually equivalent to r cos theta, or cos x rather, plus alpha, because this is the form we're trying to get it in. Now when I expand this, so I'm going to use a compound angle formula to expand this. So I'm going to have r. Now cos of x plus alpha would give me cos x cos alpha minus r sin x sin alpha. So you have 12 cos x minus 4 sin x. Now all we have to do is compare. All right, so by comparison, look at what is multiplying the cos x on the left, and look at what is multiplying the cos x on the right. On the left, you have 12, right? That's the coefficient of the cos x. On the right, you have r and cos alpha. So you're going to have r cos alpha. What about the sin x? Since you have both minus signs in the middle, we don't have to pay attention to the minus sign. We just simply need to say that 4 is equal to r sin alpha. Now, if 12 is equal to r cos alpha, we can agree that cos alpha equal to 12 over r. Likewise, we can say that sin alpha equal to 4 over r. Now, what is perfect here is to get a little right angle triangle, put in alpha, cos alpha, which is adjacent, so this will be 12, the hypotenuse would be r. Over here is unknown, but of course, sin alpha says 4. Sin is opposite, so here would be 4, and the hypotenuse would be r. Now, this brings in Pythagoras' theorem that says that r squared would be equal to 4 squared plus 12 squared. So r squared would be equal to, this is going to give me 144 plus 16. All right, that is going to give me 160. So r squared is equal to 160. And of course, we take the square root of both sides. So r would be equal to, now technically speaking, we're going to be putting this in third form. All right, root 160 is really 16 times 10. And of course, you don't even have to manually write out this to get it in third form. 16 times 10. The square root of 16 is 4. So that's going to come out of the third. And of course, the 10 remains. So it's 4 root 10. All right, in the triangle, we know the opposite side and we know the adjacent side. So we can use a tan ratio. So we can say tan alpha is equal to opposite, which is 4, over 12. So alpha is equal to tan inverse 4 over 12. Now you have to ensure that your calculator is in radians, all right? So let me go there, shift tan inverse 4 over 12. This would be 0.322 rads. So this is 0.322 rads. Okay, so find a value. So r is equal to 4 root 10. Alpha is equal to 0.322 rads. All right, so that part is good to go. All right, let me just erase this so we can have enough space to do the next part. All right, it says hence solve the equation. So hence means you're going to be using what you had at the top. So since I have r and I have alpha, I'm just going to go back to this form right here and plug in the values. So I'm going to have 4 root 10 cos theta plus 0.322. All right, so that's a form. So bear in mind that this is equivalent to this up here, and this is equivalent to this down here, which is equivalent to 4 root 10 into cos theta plus 0.32. So I'm just going to equate this to 7. All right, this is part B. All right, this I can solve like a normal equation now. So this is going to be the same thing as saying I'm going to transpose a cos. So I'm going to get rid of the 4 root 10. So I'm going to have cos theta plus 0.322 is equal to 7 over 4 root 10. All right. Now, bear in mind that there are several angles at work, so I can't just go ahead and find cos inverse. I'm going to have to create a small angle, which is alpha. Say alpha equal to cos inverse of 7 over 4 root 10. And I'm going to plug this inside of my calculator. In fact, I'm going to pull up the calculator for you to show you how we do this. We must ensure that our calculator is in radians. If you look at my calculator, you notice a small r right here. That is it. So to get alpha, all right, I'm going to press shift. Then I'm going to press cos, all right, put in my fraction bar. I'm going to have 7 over 4 root 10. I'm going to go to the n. You don't even have to close the bracket. I think one they puts in, but I'm just doing it the right way. And this is equal to 0.984. Remember, we use 3 significant figures, right? So this would be 0.984. All right, good. Now, cos, of course, is positive in 2 quadrants. And the 7 over 4 root 10 was positive. So that when I draw my quadrant, follow me carefully. Probably I shouldn't have used alpha here because this alpha and the alpha over here are different. So probably let me go, instead of using alpha to create a confusion, let me use beta because I don't want you to be confused. This is just used to find the acute angle that is going to represent the cos inverse of 7 over 4 root 10. So we know it's going to be in the first quadrant, 0.984, and it's going to be in the cos quadrant, 0.984. Good. So now what we can say is that theta plus 0.322, of course, and they should have also not been theta, but x. All right, my bad. This should be x all the way because it's the x value here. So this should be x plus 0.322 is equal to 0.984 r. Of course, to get all the way around here, I'm going to have to say 2 pi, which is equivalent to 360 degrees minus 0.984 to get that value. So let me pull up back my calculator. Once again, your calculator can do that for you. All right, so you can go, let me clear it off on. So 2 shift pi minus 0.984. That's 5.299. Anyway, you take it, we go 5.30. All right. Or 5.30. So it means that x is equal to, we simply just subtract 0.322 from both of these. All right. I'm going to pull up my calculator again. And let me move it so you can see it. So I'm going to have 0.984 minus 0.322. That's 0. So you're going to have either 0.662 rads, or if I do it with the 5.30, I'm going to have 5.30 minus 0.322. 4.978 or 4.978 rads. Of course, you can always put these inside of the equation to test it to see if the thing is correct. And it says, given your answer to 1 decimal place. Well, I'm going to leave it to the 3 significant figures because initially the question was in degrees. All right, so let's imagine that it says 3 significant figures here. We're going to be working with that, or 3 decimal places in that case. All right, write down the minimum or maximum. Write down the minimum value of 12 cos x minus 4 sin x. Once again, we're going to refer to the form that it is in, which is 4 root 10 cos x plus 0.322. All right, when you have it in this form, it's easy to know. The maximum value is a 4 root 10. The minimum value is negative 4 root 10. So whatever the coefficient of cos is, then of course you can look at the coefficient to determine the maximum and the minimum value. All right, provided that you don't have a translation, which you don't have a translation here vertically. Good. You have a horizontal translation, which is what the plus 0.322 will give you. But you don't have a vertical translation, which is what accounts for your amplitude. So from this, the minimum value is just simply equal to -4 root 10. All right, not bad there. The last part of the question says find into 2 decimal places. I'm still working with 3 significant figures, or 3DP, so ignore this. The smallest positive value of x for which this minimum value occurs. All right, so you want the angle, which x represents the angle at which the minimum value occurs. Once again, we're going to be using the form, which is 4 root 10 cos theta, well, cos x plus 0.322. All right, that's the form we're using. Now, bear in mind that the minimum value is equal to -4 root 10. All right, so we can actually say that cos theta, why do I keep saying cos theta? Cos x. So we can say the cosine of x plus 0.322 is equal to -1. All right, which is if we divide both sides by 4 root 10. Now the question is, the cosine of what gives you -1? You can solve this as an equation, but you don't need to do that because the graph is going to become handy now. And of course, they're interested in the positive values of x. So I can simply just recall the cos graph. And drawing the cos graph is pretty straightforward. We'll go up by, let me say, this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. All right, so let us see how far we're going to need to go. This is 1 up here, and this is -1 down there. So we're going to start from here. Start, we go down. Turn, we come up. We'll go up here. All right. Now, here's a problem. Since we're dealing with positive values, between these 2 intervals, there's only one minimum point. So I'm going to need to continue. All right. So I skip the 2 pi here. I'm going to add, of course, you know that pi over 2 is 90. So I'm going to have to add pi over 2 until I go with some more. So let's do that. All right. So I have a choice of continuing this graph. So if I add pi over 2 more, it's 5 pi over 2. And then it's going to be 3 pi. Although, technically, I don't need to do this because the period of this graph is 2 pi. So it starts repeating itself after 2 pi. So this minimum point that you have right here at pi is going to come back when you add a next 2 pi to that, which is going to give you 3 pi. All right, I'm just going to use a graph to prove it. And then I'm going to show you that you never really had to continue the graph at all. See? So it comes back right here at 3 pi. So all I had to do really was to say is that when you cosine pi, you get -1. When you cosine 3 pi, did I have to draw the graph all the way out there? No, because the period of the graph, which means where the graph starts repeating itself, is 2 pi. So this point here can only come back after 2 pi, and it will come back again after a next 2 pi, and it keeps going like that. All right. So it means that whatever I'm cosigning in here, whatever I cosine here must either be equal to pi or 3 pi. So it means that x plus 0.322 must either be equal to pi or it's going to be equal to 3 pi. Good. So x is equal to, which means that I'm going to have to subtract 0.322 from both of these. All right. Once again, your calculator does that for you nicely. All right. Let me remove the calculator so you can see it. So I'm going to have pi, so shift pi minus 0.322, which is 2.82. And I'm also going to have 3 pi, 9.10. So you have 2.82 rods, or you have 9.10 rods. So these are the 2 possible angles, 2 smallest angles which are positive, which will produce the minimum value. And that's the end of this question. Is that we can actually approach question 3. It says a curve has parametric equations, x equal tan squared t, y equals sine t, where t is between 0 and pi over 2. Find a Cartesian equation of a curve in the form y squared equal to f of x. All right, there are several ways I can do this. All right. one way that I could have actually done this is to use a triangle. So I know that if x equal to tan squared t, I could go right ahead and say that, okay, tan t equal to root x. All right, so I'm drawing a triangle there. All right, so put in my triangle, put angle t here. Tan is opposite over adjacent. So it means that the opposite side would be root x, as I could write it as root x over 1, and the adjacent side would be 1. Now, by Pythagoras' theorem, the hypotenuse will be the sum of the square of the other two sides. And of course, if you square root x squared is just going to give you x. So x plus, if you square 1, you're going to get 1. All right. Now, y is equal to sine t. So y is equal to opposite. Sine is opposite over hypotenuse. So I'm going to have root x over root of x plus 1. Of course, we don't like how this look because we want it in the form y squared equal to f of x. So I'm going to square both sides. Now, the beauty about this is that when I square a fraction, I can simply just square the numerator and I can square the denominator. Same thing as squaring everything. All right. Now, what happens when you square something with a root? It means that the root will be cancelled out. So all you have is y equal x over y squared equal x over x plus 1, which is exactly what they wanted. Y squared equal to a function of x. All right? That's one way of looking at it. A second way of looking at it is that you could find a connection between tan squared and sine that will allow it to be cancelled out. So that will allow you to eliminate the parameter, which is t. All right. Now, there are different ways of doing this. You have to know your trig identities at this point. So for instance, I know that if I have cos squared theta plus sine squared theta, I get 1. I know that if I have tan squared theta plus 1, I get sec squared theta, which means I could say sec squared theta minus tan squared theta equal to 1. We know that cot squared theta plus 1 is equivalent to cosec squared theta. All right, so cosec squared theta minus cot squared theta equal to 1. Now, looking at this here, if I were to square the sine, I would have sine squared t, but how would I connect sine squared t and tan squared? Even if I flip sine squared, I'm going to end up with cosec squared, which means that I would need to have cot squared. But that can be manipulated. So I could say that y squared is equal to sine squared t. Now, if I reciprocate this, I'm going to have 1 over y squared is equivalent to 1 over sine squared t. But 1 over sine squared t is cosec squared. So I have cosec squared t is equal to 1 over y squared. All right, not bad so far. What about y? Well, that means I'm going to need cot. And I know if I flip tan, I get cot. So I can simply say that 1 over x equal to 1 over tan squared t. So 1 over x is equivalent to cot squared t. All right. Now I can say that 1 is equivalent to cosec squared t minus cot squared t. So 1 is equivalent to cosec squared. From this, cosec squared is 1 over y squared. So I'm going to have 1 over y squared minus cot is 1 over x. All right, not bad so far. I need y squared to be the subject of the formula. So I'm going to bring the 1 over x here. So I'm going to have 1 plus 1 over x is equivalent to 1 over y squared. Now, of course, you want to express this as a single fraction. So put this over 1. The LCM is x. So it's going to be x plus 1 equal 1 over y squared. We reciprocate both sides. So x over x plus 1 is equal to y squared, right? Which is the same answer practically. So there are different ways of doing the same question in most cases. All right. Okay, guys, we move into question 4. And it says the line L1 has the vector equation R equal 8I plus 12J plus 14K plus lambda into I plus J minus K, where lambda is a parameter. All right, the point A has coordinate 4, 8A, where A is a constant. The point B has coordinate B, 13, 13, where B is a constant. Point A and B lies on line 1. Oh, what's the most important thing we need to know here? We need to know that all points can be written as position vectors. All right, so it means that the point A, we can get a position vector from it. So we can call it OA, O meaning the origin. All right, so as a position vector, point A is going to be 4I plus 8J plus AK. All right, same concept with B. Since it's a point, it can be written as a position vector because all position vectors are taken with respect to the origin O. B can be written as BI plus 13J plus 13K. All right. Now, bear in mind where you have the equation of a line, R in the vector equation represents any point on the line, or the position vector of any point on the line. So technically speaking, I could say that this implies that 4I plus 8J plus AK, replacing R, which is any point on the line, is equal to 8I plus 12J plus 14K plus lambda into I plus J minus K. Now, you know the concept when two vectors are equal. The components of I's are equal, the components of J's are equal, and the components of K are equal. So on the left, you only have 4. On the right, the components of I would be 8. So I would have 8 plus, well, lambda would also be in front of I. So 8 plus lambda. You can call that equation 1. All right. You could also say that 8, which is a component of J, is equal to 12 plus lambda, equation 2. Likewise, for K, component of K on the left is A. On the right, it's going to be 14 plus, well, not plus, because the coefficient of K is negative. So it's going to be a minus, right? So it's 14 minus lambda. That's equation 3. Okay, all right. So you have 3 equations. I simply just need to find lambda. So from equation 1, 4 equal 8 plus lambda. Lambda is obviously going to be minus 4. I just need to sub this in equation 3 to get A. So A is equal to 14 minus negative 4. A would be equal to 18. And there you have the value for A. Now, of course, you're going to be taking the same concept or the same approach to find B. All right. So OB, this time I'm using OB. Now, OB, which is going to be BI plus 13J plus 13K, would be equal to 8I plus 12J plus 14K plus lambda times I plus J minus K. All right? Same concept. The coefficients of I are equal. So you can say B equal 8 plus lambda, equation 1. You can also say for J, you have 13 equal 12 plus lambda, equation 2. And for the component of K is the same approach. 13 equal 14 minus lambda. Good? Now I just need to solve one of these equations in order to find lambda. Probably not. Don't need to do that because I found no. All right, so let me go here. So from this one, I can probably use equation 2. I can say 13 minus 12 equal lambda, because lambda is different for each scenario. So 13 minus 12 is 1. So lambda equal to 1 in this case. All right. B is equal to 8 plus lambda. So B is equal to 8 plus 1. B is equal to 9. So here we can state that A is equal to 18. B is equal to 9. And that's the end of this particular question, right? So we just have to know the conceptual understanding behind using vectors and so on. All right, let's move on to the second part. It says, given that point O is the origin, you know, the coordinate of the origin is 0, 0. And that point P lies on L1 such that OP is perpendicular to L1. Once again, we say once a point is with respect to the origin, or it's a coordinate, then of course it's a position vector. Hence why we have OP. Now, what is important here is that OP is actually a point on this line. So you can actually say that the vector OP, which is also the position vector, O means position vector, it's a point, and it's a position vector of a point, is equal to 8i plus 12j plus 14k plus lambda into I plus j minus k. Good? So OP, all right, we can put this together collectively as a single vector. It would be 8 plus lambda I, because we're thinking of it as being a single vector, plus 14 plus lambda j, and then you have, oh, there shouldn't be 14, there should be 12. So this is 12 plus lambda j. And then you're going to have plus 14 minus lambda k. This is the vector, all right? Now, what do we know? We know that this is perpendicular. This vector is perpendicular to the line. Now, any vector that is perpendicular to a line is perpendicular to the direction vector of the line. And the direction vector of the line is I plus j plus k, I plus j minus k. Now, what it means is that when two vectors are perpendicular, the dot product is equal to 0. So let me put this in the column form. So 8 plus lambda, 12 plus lambda. I don't have to put it in the column form, but I need some space. 14 minus lambda. All of this dot the direction vector of a line, which is just 1, 1, minus 1, is equal to 0. Good? So, of course, multiplying 8 plus lambda by 1 is just going to give me back 8 plus lambda. 12 plus lambda times 1 is also going to give me back plus 12 plus lambda. And 14 minus lambda times negative 1 is going to give me negative 14 plus lambda. And all this is equal to 0. Now looking for like terms, lambda plus lambda plus lambda, that's 3 lambda. 8 plus 12, that's 20. 20 minus 14, that's 6, equal to 0. So lambda, right away, if we care about the 6, it's going to become a minus 6 divided by 2. Divided by 3 is going to give me a minus 2. All right, so we're good to go there. Now, in order to find the vector OP, I simply need to just go back to this vector here and replace the lambdas by negative 2. So I'm going to have 8 plus negative 2 is 6, 12 plus negative 2 is 10, and 14 minus negative 2 is 16. Now, what the question asks, the coordinates, all right? Remember, all position vectors can be written as coordinates. So the coordinate of P is 6, 10, 16. All right, that's the coordinate of P. And that would be finished there. Now, part C says find the distance OP. So you want the length of the vector. Same thing as finding the length of the vector OP. Of course, you know, we use an aspect of Pythagoras' theorem here. We can say the modulus of OP, modulus of vector OP, will be the square root of 6 squared plus 10 squared plus 16 squared. And of course, we're going to pull up the calculator and have it in third form. So let me pull up the calculator here. So it's the square root of 6 squared. Notice I'm not using any bracket because I don't have any negatives. All right, if you have negatives, it will be important to use a bracket squared plus 16 squared. This is equal to 14 root 2. So 14 root 2 units. All right, and that will be the end of question 4. We now move on to question 5. Question 5 says the diagram shows a circle, center O, radius 8 centimeters. The points P and Q on the circle, lie on the circle. The lines PT and QT are tangents to the circle, and the angle POQ is equal to 3 pi over 4 radians. Find the length of it. So, all right, first of all, let's go to the diagram and analyze the diagram. Now, this is what you call the radius. The radius meets a tangent at 90 degrees, all right? So you're gonna have a 90 degree there. Likewise, you're gonna have a 90 degree down here. Now, what we know for sure is that these are 290 degrees, but as they are, we probably need to create a triangle so that we can use the trig ratios to find the various lengths. So I could divide this down the middle. Right, good so far. So the angle would be half, so this would be 3 pi over 8 radians. Now, if this is 3 pi over 8, we have the angle, we have the side adjacent to the angle, and we want the opposite side. So right away, we are in with tan. So I can say that tan 3 pi over 8 is equal to the opposite side, which is PT, over the adjacent side, which is 8. So PT is equal to 8 tan 3 pi over 8, right? PT equal, and of course, this is now a triangle work. Let me pull up a triangle. Not triangle, sorry. Calculator work. So I'm gonna have 8 tan, all right, 3 pi, so 3 shift pi over 8. Close a triangle here. That's 19.31. So PT is gonna be 19.31 centimeters, all right? That's good. Find the area of the shaded region. All right, so here's a shaded region. Now, if I can find the area of these two triangles, all right, so note, let me put in, this is 19.13, which automatically makes this 19.1, well, 0.31, since what we have here are congruent triangles. So if I can find the area of these two triangles, which would give me the area of this quadrilateral, and then I can find, of course, you realize that this quadrilateral is actually a kite, right here. If I can find the area of this kite, and I can find the area of this sector, then by subtracting the area of a sector from the area of the kite, I'm gonna end up with the area of the shaded region. All right, so let me just say area of shaded region equal to area of OPTQ minus area of sector OPQ. All right. Now the area of a triangle is half base times height. All right, we can treat this as a base, we can treat here as a height. So it's gonna be half times 8 times 19.13, of course, times 2. How do I get area of a sector when angle is in radians? All right, let me just put the formula here. Area of sector is equal to half theta r squared, right? Very important formula to know. So this is gonna be minus a half, theta is 3 pi over 4, and the radius is 8 squared. Once again, the calculator will do a nice work here. So let me just pull up my calculator. All right, put it over here so you can see it. So I don't have to put in a half times 2 because I know that a half times 2 is 1 whole. So I just need to put in 8 times 19.13 minus a half times fraction 3 pi over 4. So I'm gonna have 3 shift pi over 4. And then I'm gonna multiply this now by 8 squared, which I can just put in 64, right? Now this is 77.68. So I'm gonna have 77.68 square centimeters. Don't forget the unit. Find the perimeter of the shaded region. Okay, let me just use a space here. All right, perimeter is the distance around. So I'm looking at these two sides, which is 19.31, those two sides. And this side here, which is actually an arc. So here, I'm going to have perimeter equal these two sides, which is 19.13. But you can say times 2, really. Plus the length of the arc, which is theta r, right? That's a formula for the length of arc, theta r. So it's 3 pi over 4 times the radius, which is 8. Once again, you can put all this inside of your calculator. So let me just pull up by the calculator, put this in there, and then we're going to have the perimeter of the shaded region, right? Remember that perimeter means distance around. So I'm going to have 19.13 times 2 plus fraction 3. I'll put in the pi, 3 pi over 4 times 8. That's 57.11. So this is 57.11 centimeters. And that's how we get the perimeter of the shaded region. All right, guys, let's get right back into it. Question 6. It says the points A and B have coordinates -2, 11 and 8, 1 respectively. Given that AB is the diameter of circle C. So what I'm going to have to do is draw the circle. All right, when it comes on to diagrams involving circle, nothing beats drawing your circle. So you're going to draw your circle. A key component of your circle is the center. We don't know it. We're going to call it C. All right, we know that the endpoints of the diameter, all right, so this is AB. The diameter runs through the center of the circle. Very important. And you have -2, 11, and you have 8, 8, 1. All right. Remember that this is not drawn to scale now. It says show that the center of the circle has coordinates. So in other words, AB is the diameter. The center of the diameter is the center of the circle. Now, since the diameter is a line, we call it the midpoint. So we can say that the center, which is equal to the midpoint. Of course, the formula for midpoint is x1 plus x2 over 2, y1 plus y2 over 2. Doesn't matter which one we said we call x1 or y1, right? So I can say, all right, -2 plus 8 over 2 and 11 plus 1 over 2. This boils down to C, which is the center. -2 plus 8, that's 6. Divided by 2, that's 3. And 12 divided by 2 is 6. So the center is 3, 6, right? Which is what they wanted, QED. So we have that. Now find the, so let me put that information on. So I have 3, 6. Now it says find an equation for the circle. Okay, all right, let me just erase some of this so we can have some space. So we are at B, where it says find an equation for circle C. Okay, no problem. Remember that the standard form of the equation is x minus a all squared plus y minus b all squared is equal to r squared, where a and b is the center, which we know. So we have x minus 3 all squared plus y minus 6 all squared is equal to r squared. X and y represents any point that the circle passes through. Now we have 2 points that the circle passes through. All right, let me use B. B is 8, 1. I could also use -2, 11. It doesn't matter which one you use because the circle passes through both points. So these are my x and y coordinates. So I would have 8 minus 3 squared plus 1 minus 6 squared is equal to r squared. This is going to lead me to find the radius because I need the radius if I'm going to find the equation of the circle. Okay, 8 minus 3 is 5. 5 squared is 25. So I have 25 plus 1 minus 6 is -5. -5 squared is 25 equal r squared. So r squared is equal to 50, which means that r, we don't need to find, eventually we don't need to find r really because we're going to come back and expand the thing. All right, so we don't need to find r. So I could leave it as r squared, but just hypothetically speaking, we could say that r would be the square root of 50. And we say what's the highest square number that can go into 50? It's 25. The square root of 25 is 5. 25 times what gives you 50? 2. So you have 5 root 2, all right? Just a third form. All right, let's go now to the equation. So I'm going to have x minus 3 all squared plus y minus 6 all squared is equal to r squared. I don't have to write 5 root 2 all squared because this is the standard form. Normally when they ask you, you put it in a general form, so I'm gonna have to expand this anyway. These are perfect squares, and make sure you know your perfect square, which means I'm gonna have x squared minus 6x, so it's a squared plus 2ab plus b squared, all right? So this is plus 9 plus y squared minus 12y plus 36 minus 50 equal to 0. And you know the form, you're gonna have x squared, then y squared, minus 6x, then minus 12y, and then you have 9, so that's 9 plus 36. 9 plus 36 is 45. And 45 minus 50 is negative 5. So minus 5 equals to 0. This is the equation of my circle. All right. We'll put it in the general form if they don't tell us what form to put it in. So this will be the answer to part B. Okay, verify that the point 10, 7 lies on C. Now, to verify that, I simply just need to plug 10, 7 into the equation, and it should be equal. Well, both sides should be equal. I could either use the standard form, or we can use the general form. It doesn't matter. Okay? All right, let me say I decided to use the standard form because this probably looks much quicker. All right, so let me put this as C. So I'm gonna plug in 10, 7. So plug in 10, 7. All right, so the x value is 10. So I'm gonna have 10 minus 3 all squared plus 7 minus 6 all squared. I should get 50. Let's see if this happens. 10 minus 3 is 7. 7 squared is 49. 7 minus 6 is 1. 1 squared is 1. All right, so you get 50 equal to 50. Therefore, C lies on the circle, right? So you have that information, and you're good to go. All right, for part C, for part D rather, I'm gonna need some space, so let me just erase this quickly so I can get some space to work my final question. It says, find an equation of a tangent to C at 10, 7 in the form, yeah, give y equal mx plus c. All right, 10, 7. All right, so it means we can put 10, 7 on the circle because we found out that 10, 7 actually lies on the circle. All right, let's get right into it. All right, so let's say hypothetically speaking, I had 10, 7 right here. All right, 10, 7. We want the tangent at this point, which means I'm gonna have to draw a normal. The normal is the same as the radius. Now, why do we need a normal? The tangent only passes through 1 point. 1 point can't find the equation of a line. So I'm gonna have to find the gradient of, and it's all about the gradient. I'm gonna have to find the gradient of a normal, y2 minus y1 over x2 minus x1. Let me call this x2, y2. Let me call the center x1, y1. So I'm gonna have 7 minus 6 all over 10 minus 3, which is 1 over 10 minus 3 is 7. But that's a gradient of the normal. I'm not interested in the normal, I'm interested in the tangent. Now, because the normal and the tangent are perpendicular, the gradient of one is the negative reciprocal of the other. So the gradient of a tangent is negative 7. All right. The tangent passes through 10, 7. So we can get right into it. So y minus y1 equal mt, which is the gradient of a tangent, into x minus x1. So y minus y1 would be 7 equal negative 7 into x minus 10. So you're gonna have y minus 7 equal negative 7x plus 70. So y equal minus 7x plus 7 goes over and add to 70, gives you 77. And that will be the equation in the form y equal mx plus c. Now notice that this covers 3 topics. Module 2, it covers geometry, trigonometry, and vectors. All right. Thank you for watching. Please leave a comment and a like. Thank you.